Today we're going to talk about spanning a parapet roof in order to raise bifacial solar panels above the reflective surface. I'm Dennis. Thanks for watching. I used 20-foot lengths of unistrut. With connectors this was extended to 25 feet. Next, I stripped off the terracotta top tiles, prepped the surface and painted them with the same elastomeric paint I used on the roof. There are many strong fittings available for unistrut, including corners, 45s, extenders, and more. Just about anything you can think of, they have it. My roof is about 24 feet across, so I had a bit of an overhang with the 5-foot extension. We're going to need some additional supports, so I jacked the unistruts up to remove any droop. Now let's look at installing the feet for the next rack. First, let's get these painted and ready for install. Next, we'll drill holes to receive the 6-inch lag bolts, securing the feet to the parapet. Off camera, I used several bits to get through the multi-layers of the parapet. On top, there's tar paper. Under that is a couple inches of stucco. Finally, there's a good wood attachment point. Clean up the worksite and add silicone sealer. Next, we install the feet, one at a time, ensuring level and plumb. The difficulty in alignment increases after this step, so we want to get this right. Okay, let's torque these down good. And it's on to the next one. I picked up a standard silicone sealer and went to town. More U-channel and extensions ready to install. Here are the truss pieces I designed in Fusion 360. There is a bit of support to remove. There are 72 of these in this build, but it is a fairly easy job. Yep, still going. Let's get the power tools involved here. Okay, let's look at the attachment hardware. Notice that I'm using a rubber garden hose gasket and lock washers. I'm hoping that the rubber will mitigate plastic cracking due to stress as the wind blows. The blue nuts secure everything to the U-channel. You'll see here that at this point I still was planning horizontally oriented panels, but later decided to add 7 inches of lift to the north rail set of each rack. Next, I added some lateral supports to each rail, utilizing a flexible joint for the U-channel to accommodate the pitch of the flat roof here. Okay, let's load these truss sections onto the rail. 18 on each rail, plus steel struts on each end and the middle. That box was full of these parts. Notice my incomplete roof cleaning on the patio behind me. I'll have to work on that later. Still going. Okay, let's put the top rail on. All truss V's bolt through the top rail rather than utilizing the rail nuts. We need to cut some outrigger support legs for the bottom rails to mitigate rail flex in high winds. Dress them up and paint them. Okay, let's get these outriggers installed. I added a total of 8 outriggers in order to reduce the amount of weight on the 4 midpoint legs. In these shots you can see the difference in the rail heights finally. This took some time to get right. The midpoint leg support plates also needed to be reflective, so out comes the elastomeric paint again. This is a great view of the offset rails. And of course, we need ballast. 100 pounds on each midpoint and 50 pounds on each outrigger, secured to the legs with zip ties. End caps make this job look more professional. I designed these in Fusion 360 and printed them on my 3D printer. I secured them with construction adhesive. Now for the replacement terracotta tiles. I designed a cutout to accommodate the foot. They go in easy and look great. What a beauty! Here's a cost breakdown for the rack system. This will accommodate a total of 12 large panels, up to 500 watts each. Next steps? Testing the racks with undersized panels to catalog the wind load. Okay, talk to you soon.